Welcome, Algebra 1. This is section 6.5, linear inequalities. The essential question is, what is the difference between graphing a linear inequality and graphing a linear equation? Let's begin. So what is a linear inequality? Well, it's an inequality with two variables. So an inequality means you have one of those signs like the greater than, the less than, the greater than or equal to, or the less than or equal to. And it has two variables. And usually we're talking about y and x, because we're trying to graph something with an x and a y coordinates. So here's an example. Y is greater than x minus 3. So that's an example. A solution to an inequality is an ordered pair, so something in the form x comma y. That makes the inequality true. It must make it true. So it can be many solutions. So 5, 1 is a solution to the inequality above, because if you plug in 5 for x and 1 for y, you get 1. No, it's not a solution. Okay, is it a solution? Well, you plug in 1, you get 1 is greater than 5 minus 3. And is 1 greater than 2? No! So 5, 1 is not a solution. But let's come up with a different example. What if we did 5 dash 3? So if you did 5, 3, you'd be plugging in 5 in for x and a 3 in for y. So you get 3 is greater than 5 minus 3. 3 greater than 2. Is 3 greater than 2? Yes. So 5, 3 is a solution. And there's usually an infinite number of solutions. Now, how do we graph a linear inequality? And this is what they look like. So the graph of y is greater than 2x minus 2 will look like this, and the shade going above. And y is less than or equal to 1/3 x plus 1 is going to look like this. Notice in both you have a line in both, and we call this the boundary. This is the line that if you just graphed it, y equals negative 2x plus 2, that's basically that line right there. And this is y equals 1/3 x plus 1. And that's that line right there. And then notice they call it the half plane here. Basically, it's the shaded area. So you have two parts. You have a boundary line, and you have a shaded area. And this boundary line's dashed, and this one's solid. Well, what's the difference going on here? Let's talk about that. So graphing inequality, here's where the differences are. It's similar to graphing a linear equation, which I just explained. But first you have to graph the boundary line, which is basically the line of the equation. And you either make it dashed or solid. You make it dashed if you have less than or equal to. So it's a dashed line. The reason we have that is because the line doesn't count because you don't have the or equal to part. So you just have to do a dashed line. It says, well, everything above or below, but not on the line. Now, if you do have the or equals to, like less than or equal to or greater than or equal to, it's solid because the boundary line counts and everything that's shaded. Now, you also have to shade a side. Which side do you shade? Because there's always going to be two sides of a line. Like in these equations, we usually call these the top because it's above the line, or the bottom because it's below the line. So in every case, you're going to have one of those two. How do you know where to shade? Well, if you have y is greater than, or y is greater than or equal to, so this is greater than, you are going to shade above the line. So it'd be shading above, just like this. And you never, ever cross the line, or else. If you have y is less than, or y is less than or equal to, so this would be less than, you are going to shade below the line. So you're going to shade like this, and you never, ever cross the line. And if you do, you have to erase, because it must be perfect. Always perfect. And you shade just below the line, just like I did, never crossing. That's it. So let's try some examples with this. I'm going to graphing this inequality. So I'll walk you through the steps again. So I want to graph the line first. So that's the first two steps are basically, the first three steps are drawing that line. So first you draw the y-intercept, and the y-intercept in this case is going to be at -1. So at -1, which is right here, I'm going to draw a point, and I'm going to label this point, because let's label them. So that's going to be 0, -1. Now, what's the slope for that point? That slope is going to be 3, so which is 3 over 1. Means to draw the second point, I go up 3, 1, 2, 3, and over 1. So I'm going to graph that as 1, 2. Now I want to draw a perfectly straight line through that. But my question, is it going to be dashed or solid? Well, in this case, since it's greater than, means I do dashed. So I will draw a perfectly straight dashed line through those. And it should look something like this. That's not bad. And I will do arrowheads at each side still. So you draw your dashed line. Now you figure out, where do you shade? Well, since it's greater than, we shade above. So I'm going to shade above that line, and you must never cross or else. I'm going to use my shading tool. Yeah, so you get so close, but you never pretend I didn't cross it. You never cross, and you just shade above. And it must be a perfect shade. I know you know how to shade. And that's how you graph. So I did my boundary line, and I shaded above. Let's do another one. So if I want to shade y is less than or equal to 3x minus 1, it's very similar. My y-intercept, again, is at negative 1. I'm going to label that 0, negative 1. I want to do thicker lines. And so that's going to be at negative 1. And my slope's going to be 3, which is 3 over 1. That's too much. So up 3 over 1 is going to be right here. And I'm going to label that, it's going to be, oops, not 2. It's going to be at 1, 2. And now I want to draw my line through it. It's going to be dashed or solid. Well, since it's less than or equal to, this is going to be solid because the or equal to part. So I'm going to draw a perfectly straight solid line through those. Perfectly straight. Yeah, with the arrows. Now, where do I shade? Well, since it's less than, I'm going to shade below. So below that line, and you have to do it perfect, I'm going to shade below the line, just like this. Sometimes it's hard to see where it's below. I know this is to the right, but just like take any point and go straight down. And then you start doing down, you're like, oh yeah, it's straight below this point. So you must shade perfectly, just like I am. Perfect shade. Never crosses the line. And that's it. Alright, we have two special cases here. The case where you have like x is greater than or equal to a number, or y is greater than or equal to a number. These were lines that were not angled. They're straight up and down or left and right. In the case of x equals negative 1, that's going to be straight line, a vertical line at x equals negative 1. Since it's or equal, it's just the greater than part, it's not the or equals to, I'm going to do a dashed line at x equals negative 1. That goes straight up and down. Just like this. The arrowheads. And now greater than, now there's no, you can't just graph above and below, right? It's straight line, it's either left or right. We'll read that. When it says x is greater than, do you think the x numbers are going to be bigger or smaller? Well, they should be bigger. So the bigger numbers for x go this way. So I'm going to shade to the right. I'll shade that in green. So we'll do a perfect shade just like I did right there. And that's that graph. Now for y is greater than 2. Well, that happens, it's going to be a horizontal line at y equals 2. Since it's or equals to, it's a solid line. So you do a perfectly straight solid line, and it says y is greater than. Well, greater than is going to be shaded above. So I'm going to do a perfect shading above. Oops, nope, I didn't cross. You didn't see that. Perfect shading above, and that was a perfect graph. All right, pause the video for examples. Alright, is the ordered parity solution to y is greater than x minus 3? So we're going to plug in each and figure it out. So for the first one, 1 for x, 2 for y, I get 2 is greater than 1 minus 3. So 2 is greater than 1 minus 3 is negative 2. 2 greater than negative 2? Yes. So it is a solution. Now I'll try this one. Get negative x and y. Negative 7 is greater than negative 3 minus 3, which is negative 7 greater than negative 6. Is it? No, it's less than. So we say no. Next one. Graph that. Alright, let's try this. My y-intercept is negative 2. Your b equals negative 2. So I'm going to put a dot at b. I'm going to label it 0, negative 2. My slope, m, is going to equal 1, which is 1 over 1. So I go up 1 over 1. And that's my next point. And I'm going to label that 1, negative 1. Now I'm going to draw my line through that. Is it solid or dashed? Well, in this case, because it's greater than, it's going to be a dashed line. So I'm going to draw a perfectly straight dashed line going in both directions, perfectly straight. I use my straight edge and draw the arrowheads. And now I got to figure out where do I shade. Well, since it's y is greater than means shade above. So I will shade above that line, and that I will do this in yellow. So it's going to be shading above the line, just like this. And I never cross, and then I'm going to shade the rest. Yeah, perfect. Next one. Alright, pause the video. Okay, so it's going to be a 1 right here, and I will label that 0, 1. And then your slope m is 1/2, so I go up 1 over 2. Another dot right there, and that's at 2, 2. And now I want to draw a line. Since it's less than or equal to, this is going to be a solid line, just like that. So I will draw a solid line going through those 2 points. And a perfectly straight, solid line going in both directions. Yeah, perfectly straight. And now where do I shade? Well, since it's less than or equal to, I'm going to shade below. So if I shade below, it's going to look like this. I'm going to shade below the line, just like this. And this is what you can do first. Oops, you never cross the line, and I never did. And then you just start shading in. And it's done. It's perfect. Yay. That's it.